All right, so now we're working with the helicopter and the box, and we see that it's 70 kilograms and a rope of 5 meters, and this is just like extraneous information, not really needed, and accelerates upward at an acceleration of 5.2 meters per second squared. So we need to draw and label the forces. So we've got this tension, and we've got this mg, and that's all. And don't touch it again. And now we want to determine the tension in the rope. So let's draw this free body diagram again. So we've got this tension going up, this mg going down, the acceleration is also going up. So we've got the sum of the forces equals ma, which is going to equal this tension minus this mg. So to find tension, we just add mg to both sides, and then so we get tension equals ma plus mg, and plug everything in. So tension equals this 70 times this 5.2 plus this 70 times this 10. All right, and when we put all that in our calculator, we get 1,064 newtons. And that is for that one. So then we've got, we cut the rope, and the when both the helicopter and the box are going 30 meters per second. And so the rope is cut, the helicopter continues to accelerate upward, but we know that since Earth is acting on this box right here, we have got now just the acceleration of gravity. So just mg is going on here. So after we cut that string, we just have the acceleration of gravity acting on that box. And so we want to determine the distance between the helicopter and package 2 seconds after the rope is cut. And so how we're going to do that is we need to find, so first, what is the change in y of the helicopter, and what is the change in y of the box. And so we know that this box, even after it's cut, it's still going to go up a little bit because it's got this initial velocity of 30 meters per second, but it's going to slow down due to the acceleration of gravity. But this helicopter is just going to continue to accelerate upward, whereas the box is going to go up and it's going to slow down and start to come back down again. So first let's find the change in y of h, so the helicopter. So let's look at what we know. We know that acceleration is 5.2 meters per second squared. We know that t equals 2 seconds, and we know that v naught equals 30 meters per second. So using all of that information, we can just plug it into that wonderful, beautiful equation of change in y equals v naught t plus 1/2 at squared. So we get change in y equals this 30 times this 2 plus 1/2 times 5.2 times 2 squared, and we end up with a change in y equaling 70.4 meters. So this is of the helicopter. So now looking at the box, we know that the acceleration of the box is going to be negative 10 meters per second squared. T is again 2 seconds, and V naught is 30 meters per second. So again, we can use this equation. This change in y equals V naught t plus 1/2 at squared. So we get change in y equals 30 times 2 plus 1/2 times negative 10, because our acceleration is going downward now, and times this 2 squared. So you end up with this change in y equaling 30.4 meters. And so while this one, the helicopter's traveled up 70.4 meters, this has only traveled 30.4. And so what's the difference between that? How far apart are they now? We just subtract. So we're going to say 70 point, oh wait, sorry, this is not the correct, that's your final answer. So this is going to end up being 40. If you plug it in your calculator, it's going to end up being 40, sorry. So we get 70.4 minus 40 is going to equal this 30.4 meters. All right, and that's going to be how far apart the helicopter and the box are.